purpose of this program is to acquaint you with the operating principles of air conditioning units used in international light-duty vehicles and the troubleshooting procedures used to isolate common problems. The function of an automotive air conditioning unit is basically the same as any mechanical refrigeration system, such as a home refrigerator or freezer. The refrigeration system is not complicated, but you should understand the basic laws of heat transfer. Unlike heat, cold is not a quantity, but an absence of heat. A refrigeration system, then, does not make an area cold by supplying cold, but by removing heat. Very simply stated, this is done by blowing warm air over a heat-removing substance, which cools the air by taking away the heat. The heat-removing substance used in automotive air conditioning systems is refrigerant 12. When properly handled, it is non-explosive, non-flammable, and non-corrosive. Although refrigerant 12 is considered a safe refrigerant, certain safety precautions must be observed when servicing air conditioning systems. The most important safety precaution is the use of safety goggles to protect the eyes. Liquid refrigerant 12 vaporizes at 21.7 degrees Fahrenheit below zero. Because of this low evaporating temperature, liquid refrigerant tends to freeze anything it contacts. If splashed on the eyes, it may freeze the eyeball and could cause blindness. If it contacts the skin, frostbite will occur. Therefore, long-sleeved clothing should be worn. Do not smoke or use any type of fire or flame when servicing the refrigeration system. Refrigerant 12 is not combustible, but when exposed to flame, it changes to a highly poisonous and deadly phosgene gas. Because liquid refrigerant evaporates so rapidly, the resulting gas may displace the oxygen in a small enclosed area. Therefore, always discharge the refrigerant out of doors and use a well-ventilated area when servicing the refrigeration system. Never weld, solder, steam clean, or use excessive heat on any of the refrigerant lines or components of the system while it is charged. The excessive pressure buildup caused by the heat could cause an explosion. Go to your response booklet and complete exercise number 1. Restart the projector when you have finished. In addition to the refrigerant, the automotive air conditioning system consists of a power source or engine, compressor, condenser, receiver dryer, expansion valve, evaporator, and blower. The temperature in the passenger compartment is regulated by a thermostatic control, which turns the compressor on and off by engaging and disengaging the electromagnetic clutch. When the temperature rises above the setting of the control, the electromagnetic clutch is energized and the compressor begins pumping refrigerant through the system. The refrigerant enters the compressor in a low-pressure vapor state. The compressor compresses, superheats, and propels the refrigerant vapor through the hoses to the condenser. The refrigerant vapor, now under high pressure, travels through the condenser coils, where the air flowing over the condenser removes the heat from the refrigerant and causes the vapor to condense into a liquid. From the condenser, the refrigerant enters the receiver dryer unit as a high-pressure, lower-temperature liquid. In the receiver dryer, the refrigerant is stored and moisture is removed by a chemical agent. Next, the liquid refrigerant moves to the expansion valve, which meters the flow of refrigerant into the evaporator. The metering process is controlled by a temperature-sensing bulb attached to a diaphragm on the expansion valve by a capillary tube. The sealed bulb is fastened to the refrigerant return line on the evaporator and is filled with a gas which expands and contracts according to the temperature of the refrigerant leaving the evaporator. As this temperature increases, the gas in the bulb is heated and expands, raising the pressure above the diaphragm in the expansion valve. The increased pressure opens the metering valve, allowing more refrigerant to enter the evaporator. When the temperature of the refrigerant leaving the evaporator drops, the gas in the sensing bulb contracts, reducing pressure on the diaphragm. This allows the metering valve to reduce the flow of refrigerant to the evaporator. When the liquid refrigerant enters the evaporator through the expansion valve, the pressure is decreased and the refrigerant is vaporized. As the refrigerant vapor moves through the tubing in the evaporator, it absorbs heat from the air blown over the evaporator coils by the blower. The compressor pulls the heated vapor from the evaporator and the cycle begins again. The refrigeration cycle continues until the temperature reaches the setting of the thermostatic control, which then stops the flow of current to the electromagnetic clutch, stopping the compressor. Go to your response booklet and complete exercise number 2. Restart the projector when you have finished. Now let's see how the troubleshooting procedure is used to isolate one example of an air conditioning complaint.
I bought this vehicle last summer and the air conditioner worked perfectly, but now it only works part of the time.
Tell me exactly what happens when you turn on the air conditioner.
Well, when I first turn it on, the air is cold for a while, and then it starts heating up. After a short time, it starts cooling off.
There are several things which could cause this condition. It could be a faulty expansion valve or saturated receiver dryer. Or it could be caused by a defective thermostatic control, a slipping compressor clutch, or something as simple as a loose wire. But we'll have to go through the whole system to check it out. Give me your telephone number and I'll give you a call when it's ready.
When isolating the cause of this or any other air conditioning problem, the entire system should be checked out before repairing or replacing any components. The following checks should be made in an area no colder than 65 degrees Fahrenheit. First, make under-the-hood checks with the air conditioner set for maximum cooling and the blower set on high speed. Check the sight glass for bubbles, indicating a low refrigerant charge. A clear sight glass could indicate either a fully charged system or no charge. To determine whether the system is charged when a clear sight glass is observed, turn the air conditioner on and off. If the system is fully charged, you will see some frothing or bubbling in the sight glass as the system is turned on and off. Then the sight glass will become clear. Remove any accumulation of leaves, bugs, or other debris from the condenser fins. If the passage of air is restricted through the unit, excessive refrigerant pressures may result. Also check for proper operation of the fan and correct coolant level in the radiator. An overheating engine will affect the performance of the air conditioning unit by reducing the cooling efficiency of the condenser. Visually check the brush contact on the electromagnetic clutch slip ring. Check the clutch for proper operation. If it is working properly, you will hear it click as the clutch is engaged. Check the compressor drive belt tension and condition, and adjust or replace as necessary. Check the compressor pulley for correct alignment with the drive pulleys and correct if necessary. Make a physical check of the refrigerant lines with the air conditioner operating. Feel all the refrigerant lines to see if they are hot, warm, or cold where they should be. From the discharge side of the compressor along the high pressure line through the condenser, everything should be hot to the touch. From the condenser through the receiver dryer and up to the expansion valve, everything should be warm to the touch. From the expansion valve through the evaporator to the suction side of the compressor, everything should be cold to the touch. Go to your response booklet and complete exercise number 3. Restart the projector when you have finished.
This line to the condenser isn't hot. Let's see what's happening on the other side of the system. Yep, the line from the evaporator is not cold. I'll bet there's ice in the expansion valve. I'll let it run for a few minutes to see if the line to the condenser heats up. According to the service sheet, the customer complains of alternate cooling and heating. If that's the case, the low pressure line to the compressor should cool off, and the high pressure line to the condenser should heat up when the system starts working again.
One problem area has been found. While waiting to make another check of the refrigerant lines, the technician makes use of this time to troubleshoot possible problem areas in the passenger compartment. First, he checks for proper operation of the control cables. Then he checks for proper routing of the vacuum hoses. Next, he checks the expansion valve sensing bulb to be sure it is insulated and properly clamped and positioned next to the evaporator outlet line. While at the evaporator, the technician checks the thermostatic control switch probe and wiring connections. The probe should be at least 8 inches into the evaporator core between the evaporator fins. A slight drag should be felt, indicating good fin contact. Finally, he checks for proper electrical connection of the relay on the top of the evaporator case.
Everything inside checks out. Now I'll recheck the refrigerant lines. The line to the condenser is heated up and the line from the evaporator is cold. Since everything else checks out, this may indicate excessive moisture in the system. To verify the diagnosis, I'll connect the service hoses from the portable air conditioner service station and check the operating pressures.
To check the operating pressures, remove the caps from the compressor service valve stems and check to see that the stems are in the back-seated position. Then remove the caps from the compressor service valve ports. Connect the manifold suction gauge hose to the compressor suction service valve port. Connect the manifold discharge gauge hose to the compressor discharge service valve port. Check to be certain the manifold suction and discharge gauge valves are closed. Open both compressor service valves one turn clockwise. Loosen the center hose fitting at the manifold and crack both manifold gauge valves for 10 seconds to purge air from the service hoses. Operate the engine at 1300 RPM for 5 to 10 minutes with doors open, vents closed, air conditioning set for maximum cooling, and the blower set on high speed. Read and record the pressures registered on the manifold suction and discharge gauges. Refer to CTS 2622M for correct pressures. Pressures will vary according to ambient temperature as indicated in the performance chart.
The suction gauge reading drops into a vacuum and the discharge gauge reading is below normal. After a few minutes, both gauges read normal pressures. These fluctuating pressure readings verify the diagnosis of excessive moisture in the system. The receiver dryer is saturated, and when enough moisture collects in the expansion valve, it freezes, stopping the refrigerant circulation. Then when the valve warms up, the ice melts and the refrigerant begins circulating again until enough moisture builds up to freeze the valve again. I'll replace the receiver dryer unit.
After completing the pressure checks, stop the engine and backseat both compressor service valves by turning the valve stems counterclockwise to the end of their travel. Go to your response booklet and complete exercise number 4. Restart the projector when you have finished. Before replacing the receiver dryer, the system should be checked for leaks. Let the air conditioner run and check the system for leaks with a leak detector. Check the manufacturer's operating instructions for the leak detector you are using. When using an electronic leak detector, calibrate the detector according to the instructions and check for leaks at a rate of 1 inch per second. The leak check should include the high-pressure fuse plug located near the sight glass on the receiver dryer. If a leak is detected, the receiver dryer must be replaced. After checking the system for leaks, turn off the engine and air conditioner. Before discharging the system, take all necessary safety precautions. To discharge the system, open the compressor discharge service valve port by turning the valve stem clockwise 1/2 turn. Place the hose from the center fitting on the manifold gauge set in a well-ventilated area, preferably out of doors. Open the manifold discharge gauge valve a slight amount and allow the refrigerant vapor to discharge slowly. Do not allow the refrigerant vapor to discharge too rapidly, as it will carry out the compressor oil as well. After the refrigerant has been discharged, both manifold gauges will read 0. Go to your response booklet and complete exercise number 5. Restart the projector when you have finished. System components can now be removed for repair or replacement. In this case, the receiver dryer will be removed and replaced by a new unit. Cap each hose as it is removed from the old receiver dryer unit. Do not remove the caps from the new receiver dryer unit until you are ready to connect each hose. Lubricate hose connections and the back side of the female flange seats with refrigerant oil before installing them on the receiver dryer. Also, tighten any loose fittings and replace any hoses found to be leaking. After the repairs have been completed, evacuate the system to remove all air and moisture. Use the high vacuum pump SE2446 and the high vacuum meter SE2447, both of which are standard on air conditioning service station SE2443. Close all valves on the service station. Then attach the hose from the center fitting on the manifold to the hose bracket on the service station. Set both compressor service valves in mid-position by turning the valve stems clockwise to the end of their travel, noting the number of turns. Then turn them back 1/2 this number of turns. Open both manifold gauge valves by turning them fully counterclockwise. Start the vacuum pump and slowly open the pump blank-off valve. After the suction gauge on the manifold shows that the system is in a vacuum, open the vacuum gauge control valve on the service station and continue to operate the vacuum pump for 10 minutes. Caution, do not apply positive pressure to the system when the vacuum gauge control valve is open, or damage to the vacuum gauge tube will result. Close the pump blank-off valve and watch the electronic vacuum gauge for 1 minute. The meter should not indicate a rise of more than 5 millimeters. If the gauge rises more than 5 millimeters in 1 minute, the system has a leak which must be repaired. Open the pump blank-off valve and continue to operate the vacuum pump for an additional 20 minutes. While the system is being evacuated, fill the heated charging cylinder SE2448 with refrigerant 12 according to the manufacturer's recommendations. Make sure all the valves on the charging cylinder are closed after filling. After evacuating for 20 minutes, close the pump blank-off valve and watch the electronic vacuum gauge. If the gauge stays below 4 millimeters for 2 minutes, the system is ready to be charged. With the vacuum pump still operating, close both manifold valves, the vacuum pump blank-off valve, and the vacuum gauge control valve. Turn off the vacuum pump and disconnect the hose from the hose bracket on the service station. Go to your response booklet and complete exercise number 6. Restart the projector when you have finished. To charge the system, connect the center hose of the manifold to the bottom valve on the charging cylinder. Open the bottom valve and loosen the center hose connection at the manifold for 10 seconds or until the hose fitting becomes cold to purge the air from the supply hose. Then tighten the center hose connection at the manifold. Turn the compressor suction valve stem counterclockwise to the end of its travel, backseating it. The compressor discharge valve should still be in the mid position. With the engine off, open the manifold discharge gauge valve and meter the amount of refrigerant specified in the air conditioning service manual. Be certain you do not overcharge the system, or excessively high head pressures will result when the system is operating. When the system is fully charged, close the bottom valve on the charging cylinder and the manifold discharge valve. Slowly loosen the hose connection at the bottom valve on the charging cylinder and allow the refrigerant pressure to bleed off. Then disconnect the hose from the valve. Go to your response booklet and complete exercise number 7. Restart the projector when you have finished. Read and record the operating pressures with the engine running and compare them with the pressure chart in CTS 2622M. High discharge pressures can be caused by an excessive refrigerant charge, air in the system, an overheated engine, a restricted condenser air passage, kinked refrigerant lines, or overfeeding of refrigerant by the expansion valve caused by a valve stuck open or an improperly insulated feeler bulb. Low discharge pressures may indicate insufficient refrigerant, a defective compressor, or underfeeding of refrigerant by the expansion valve caused by a valve blocked by ice or dirt or by a defective feeler bulb. Low suction pressure may be caused by insufficient refrigerant, a restriction in the lines or receiver dryer, a broken expansion valve capillary tube or lost charge, a frozen or sticking expansion valve, or a faulty thermostat. High suction pressure may indicate leaking or broken compressor valves, a damaged compressor gasket, a slipping drive belt or magnetic clutch, or overfeeding of refrigerant by the expansion valve caused by a valve stuck open or an improperly insulated feeler bulb. Check the louver temperature against the performance chart. Temperature readings will vary with room temperature and relative humidity. If the operating pressures and temperature readings are within specifications, stop the engine and backseat both compressor service valves by turning the valve stems counterclockwise to the end of their travel. Disconnect the manifold hoses from the compressor service valves. Install the caps on the service valve gauge ports and valve stems and check the system for leaks. Because some of the oil from the compressor sump is picked up and circulated through the system with the refrigerant, the crankcase oil level must be checked. With the engine operating at 1200 to 1400 RPM, operate the air conditioner at maximum cooling for approximately 15 minutes. Stop the engine, remove the service valve stem caps, and turn both service valve stems fully clockwise until they are front-seated. Loosen the cap on the discharge service valve port about 1/4 turn and allow the refrigerant vapor to escape until the compressor is relieved of pressure. Remove the oil filler plug and insert a 1/8 inch diameter steel rod through the filler hole until it bottoms in the compressor crankcase. Remove the dipstick, measure the wetted portion, and compare it with the correct oil level specification. Add or remove oil until the correct oil level is obtained. If oil must be added, be sure to use only the proper refrigerant oil designated for that compressor. Consult the latest edition of your air conditioning service manual for oil specifications. Inspect the O-ring on the oil filler plug for damage and replace if necessary. Then install and torque the plug. Open the suction service valve slightly for about 10 seconds to allow air in the compressor to bleed from the discharge service port. Then tighten the discharge service valve port cap and fully backseat both service valves. Check both service valve stem caps to see that the gaskets are in place. Then replace the caps over the valve stems. Recheck the sight glass to be sure the system is full. Then road test the vehicle. Go to your response booklet and complete exercise number 8. Restart the projector when you have finished. After completing your work, check the vehicle for grease spots and remove any debris left during the service procedure. This completes the air conditioning system troubleshooting procedure for light-duty vehicles. For additional information, specifications, and torque values, refer to the latest edition of the Heating and Air Conditioning Service Manual for the vehicle on which you are working. If you would like additional training in the basic theory and service procedures for automotive air conditioning systems, contact the International Regional Office for the Truck Training Center schedules.